Hey guys, this is Miss Adams, and today we're going to be talking about graphing systems of equations. And before we get into the systems of equations, we've actually got to talk about the average rate of change. So you'll see it referred to as AROC. This is also known as the slope of a line. The slope of a line is the steepness of a line. We also refer to this as the ratio of the change in y to the change in x. What that means is when you're going up or down on the y-axis, so if you're looking at a graph and you've got 2 points and you're trying to decide the length between them, or the steepness between them, you're going to be moving up and down and left to right. And we're actually the slope is the ratio, the average rate of change is the ratio of this change in y over the change in x. So you guys have probably seen slope called rise over run. What is the rise? The rise is just your change in y, which is going to be the numerator of your average rate of change. If you go up, if you're thinking about a coordinate plane, anytime you move up or to the right, those are positive motions. Anytime you go down or to the left, those are negative motions. So if we're talking about rise, up is positive and down is negative. So with rise, you also have run. That's going to be your change in x. That's how you go from left to right. You're moving in a horizontal motion here. So your run is your change in x. And with our run, if you go to the right, you're going in a positive motion or in a positive direction, and if you go to the left, your run is negative. So let's think about some rules here. If you have, let's say I have a positive divided by a positive, that's going to be a positive number, correct? Same thing with slope or your average rate of change. If you're going up and to the right, so if we're looking at this first graph, we're going up, so we're rising, up, and we're going to the right. That is a positive motion. So in this case, this slope of this line, or the average rate of change of this line, is positive. Let's look at the next one though. If I'm going from point 1 to, let's just say, point 2 here, I'm going to go down. Well, down is a negative motion, but we're still going to the right. So now I've got a negative divided by a positive. That's going to be negative. So this is a negative slope. And then we have two special types of slopes. I think of these kind of like roller coasters. So I know it's a positive feeling when I'm going uphill. So you're building excitement. That's a positive feeling. And sometimes your stomach feels negative when you're going on that downhill of the roller coaster, right? Same thing too. Think about those kiddie roller coasters that you rode when you were little. They didn't go up or down. They didn't really go left or right. It was just kind of like riding on one little plane. Sometimes I say it's like riding with your grandma, unless your grandma's super cool. Then it's just kind of boring. You're not moving any. You're not going up or down any. You're just going left to right, just a horizontal motion. We're going to call that a zero average rate of change, or it's a zero slope. Because there's nothing's happening in your numerator there. There's no rise. Your y is staying the same. This graph is going to be y equals some sort of number. Likewise, we have an undefined slope. Think about if you've ever visited Six Flags, or if you've ever ridden one of those rides like the Tower of Terror. You don't know when you're going to drop, so your adrenaline is just building, and you drop straight down. Well, you're not going left to right any. You don't have a slope here. Alright, so the line is vertical. That means x is going to equal some number. Because you're not changing, like your value of x does not change. So in this case, if I'm looking at this graph, x equals -4. Alright, the line is vertical and it has an undefined slope. So this first one was a positive slope. The second graph was a negative slope, and I'll clean that up just so you guys can see that a little bit easier. The third one was a zero slope. We said y equaled some number, and in this case, y would equal 4 for this graph. And the last one, x equals some number. This is actually an example of x equals negative 4. So let's look at some examples here. And I'll let you guys do the U-tries. Let's look at this first one. It says determine the AROC of the following graphs. That's your average rate of change. Same thing as your slope. So looking here, I'm just going to pick 2 points on this graph. I'll start here at the origin, so 0, 0, and I'll go up to, let's say, 1, 3. Because those are nice little even points on the graph. I know I'm going up, let's see, 1, 2, 3. So I have a rise of 3, and then a run of 1. So my average rate of change is 3 divided by 1. And that reduces to an average rate of change of 3. But if I look at example problem 2, that is a vertical line. Anytime you see a vertical line, you know it's going to be something divided by 0. In math, if you divide something by 0, it is undefined. So therefore, your average rate of change here, or if you have a fraction that has a denominator of 0, is undefined. So our AROC here is undefined. Alright guys, keep tuned for the next lesson.